Okay. Your exam covers everything, right? Everything. What's 8 again?
Anthem structure cycle to dot and cross.
Dot and cross. Okay. Okay, but let's go through all this. Okay, come. 1. That one should be obvious. Strike back. Okay, good. But of course, if you are guessing or if you're not sure, voice out. 3. Okay. 4. 5. 6. Accurate measurement of water. Hold on. But you know all the 3 things there or not? I mean, all the four items there. I'll show you. This tool will definitely be used sooner or later. This is a feedback. It's for liquid. Okay, and notice this one is designed for 50 ml. When you suck up to this line, so it's a fixed volume. You can't adjust it. And the whole to break it out, of course. Yeah, only liquid. So what they do is I don't have the pump, but there's actually a pump on top. You dip it into a liquid, use a pump, and it allows you to suck up the liquid up to this line. And then once you reach this line, you stop sucking. Okay, and then you transfer somewhere else, maybe into a beaker, and then release all the liquid there. Okay, so remember, only for liquid. It's quite accurate. Depending on your school, it can go down to 2 decimal places. Okay, this is a big bag. And you have to differentiate it from a burette. Can you see all the markings? So it allows you to actually have a variable volume. Liquid as well. So this one, what you do is, this is a valve. This is closed, and this is open, so the liquid will drip out. What you do is, you pour the liquid from the top, and then normally for us, you pour up to the 0 mark. So let's say if you want to release 10 ml, 10 ml is here, 10 is there. I open the valve. Okay, this is closed. This is open. So from 0, it will drip down to 10, and then you have your 10 ml here. Okay, also for liquid. Your school mentioned this? No. You did. Oh, they did. Okay. Okay, both pipette and burette are for liquids. Burette, a few things maybe I write down for you as well. For burette, is a variable volume. You can adjust the volume. Whereas for pipette is a fixed volume. Liquid as well. Okay, but that's not all. Burette, what's the maximum? I don't think you noticed, right? Yep, but there are 2 types, 25 and 50. All right, 25 or 50, very standard. You don't have more than that. Okay, for pipette, this is about the max also. Oh, no, not the max. Max is about 100. So max is 100. The size in terms of the size. Okay, but that is not all. For this, you can measure down to 2 decimal places. However, the last digit here must be 0 or 5. So most schools won't ask this until this kind of level, but 2 decimal places, normally that's what they ask. Did your school mention about pipette? What's the degree of accuracy? How many decimal places did they mention that? Normally, most schools will tell you 1 decimal place. Of course, it goes without saying. The last digit is 0 because it's a fixed volume. These are based on the what the schools will teach, but in real life it's not, because if you notice, this one is 2 decimal places. Okay, round bottom flush, I assume you know what that is, do you? Yes, huh? Okay. So, yep. Most accurate will be burette, according to the school. All right, so that's my answer, C. And notice 38.4 is still within 50. So you can still use a burette. Okay, let me see. I don't think they are in. Yeah, then we shall go on. 7? 7, yeah. Okay, good. Yeah, not sure. Made from petroleum and has poor electrical conductivity. It floats on water. It's harder than ceramics, denser than most metals. It will scratch. Okay. What do you think is made from petroleum? Well, okay, let's assume it's a solid lah. It's not a liquid or gas. The first thing that comes to mind, plastics. I hope you realize all these plastics all come from petroleum. Okay. So, which one do you think is correct? If you know it's plastic. Plastic is not usually not that hard. It's not that dense. Okay, but try to remember the link between plastics and petroleum. So can I assume you know what's petroleum? The black crude oil. Okay. Aluminium, number 9.
Okay.
Higher density in the aluminium. Okay. 10. Okay, good. Yeah. Okay, hold on. This one can you? I have mentioned this before, but I want you to jot down once you see the word burn. Burn, there's another word for burn, is combust. Again, make sure you remember this, it's going to come up sooner or later. And therefore, any combustion is always a chemical process. Okay, and chemical process always produces a new substance. But in this case, you have magnesium, it burns in air. What component of air do you think is burning? What do you need for burning? Yeah, okay. You're no longer in primary school, so you need to know it's oxygen that is burning. And of course, these two combined together, basically they form magnesium oxide. which is of course a new substance and is a compound containing magnesium and oxygen. Heating is by itself is not. Because heating means you just expand something, that's all. But of course, by itself is not, unless you heat two different substances and then they have a chemical reaction, then it becomes a chemical process. But burning combustion, yes, it is. It is a chemical process. Sure. One compound and one mixture. Okay, this one is tricky. You have to remember, what is brass? It's an alloy. Has your school mentioned alloy? No. Okay. But basically, an alloy is always a mixture of one metal with at least another element, at least one other element. But I guess the keyword is mixture. Now, for this case, brass, if you can remember, if you can, is basically a mixture of zinc and copper. Right. So, of course, this is a compound. And of course, this is a mixture. How about air? What is air? Yep, good. Water? Iron? Good. Calcium oxide? Okay, good. 13? Okay. Okay. 16? Yeah. Okay. Cats and birds. Actually, I'm not wrong. No. Oh, no, okay. Not cats and birds, cats and fish. No wonder I saw wrongly. Fish are always cold-blooded. What are the two warm-blooded animals you know of? And yep, only mammals and birds for warm-blooded. Okay, hold on now. I pressed something wrong. Before waiting for that. What's meant by vertebrates? Okay, meaning animals that have a backbone. So I think it's easier to ask you, what kind of animal? Okay, what's the opposite of vertebrates? All right, you may want to know the other word, which is the opposite, invertebrates. I think it's easier to tell you what are invertebrates, insects. They have no backbone and obviously no skeleton either. Obviously, worms. Yeah, I won't tell you the scientific name unless you want to know it. All the crustaceans, crabs. streams. Okay, I won't say more than that. So, yeah, obviously, fish have bones. Most of them have anyway. Cats have too. All right, let's go on. 18. Okay, good. 19. Okay. 20. 21. 22. Okay, good. 23. 24. 25. Mass number, nuclear number. So you have to remember protons and neutrons. Oh, by the way, do you know what's meant by nuclear number? It means whatever in the nucleus, the subparticles in the nucleus. That's why they call nuclear number. So obviously, you have protons and neutrons in the nucleus. Okay. Subparticles in nucleus. Were you just careless for this one? Oh. 26. 27. Okay. 28. You say D for dog. Oh, okay. Yep. 29. Convex mirror. This one a bit hard lah. Convex basically means it must be smaller or larger. I mean, pick one. Convex is larger. Is sorry, hold on. Image on the rear view mirror is not larger than the object. Convex is smaller. Convex, you know what's convex, huh? Like that. Now, the advantage is wide angle. Right, you can see a wide angle, but the image is diminished. Now, of course, you realize that that is the opposite of a concave mirror. All right, so this one is a narrow angle, but the image is enlarged. I think nothing much, just have to remember that. Okay, let me go on. 30. You say D for dog. Oh. Concave mirror is for enlarging, which is what they use for by the dentist, so that they can see your teeth better. Okay. Yeah, I think that's all. Do you know what's meant by virtual? Virtual. Okay. This one common question. What's an element? Okay, good. Lim, confirm?
Substance made of two or more elements chemically combined.
Okay, good. Make sure you have the word chemically combined. Okay, what do they show? X, Y, and Z? Oh, do you do this? What did they show? No, which of the, it shows a mixture. You put Y, yep. Explanation?
Compounds and elements.
Okay. Now, just one point. The first thing you wrote is, you say that mixture is a substance. You say that mixture is not a substance. Mixture is a combination of substances. It's not a single substance. Okay? So, yeah, make sure you don't write that. Mixture is simply a combination of substances, not chemically combined together. But of course, your second part is correct. Basically, picture Y shows an element and a compound. Okay. This one, okay, I'll show you the answers. Make sure you should get them correct. You should. It's not here, one. Right, check your answer.
Structure.
What's your question again?
Structure.
Is that what they say? Atomic structure. This one is tricky. And normally they'll say something like electronic structure. Does your school have a perspective on it? Because if I show you the model answer, that one is an electronic structure. But the question did ask atomic structure. So for me, I would think that you have to include this inside. Okay, so this will constitute an atomic structure, but you're right. I hardly see any schools asking about atomic structure. So, but of course, on your part, you have to be careful. Look at your question carefully. Your school very particular about all this north, south, east, west, north, south, east, west thing. Okay, then you follow suit. Okay, arrangement and movement. I think I emphasized to you before, your class before, they always ask about this things, arrangement and movement. So look carefully, make sure you answer both. But anyway, in this case, they ask you to draw water molecules in ice. What do you draw? You don't need to do it. Normally they will. Actually, most schools will ask for that, but normally for vibrating, they just do it. Of course, you're right. They're all packed very tightly together. They'll normally draw something like this. And just a small note as well. Look at. I suggest even my one is not that good. Try to draw like right at the bottom. Yeah, because some schools are very particular. They say that why is your eyes floating right at the top there? It should be right at the bottom. Oh, this is a solid. Same thing for liquid. Try to remember that. Make sure you draw right at the bottom because your school can be quite particular. Okay, why a liquid can flow but a solid cannot flow? Yes, how do you answer? Okay, yeah, that's fine. Because that answers both. Make sure you mention a solid and a liquid regarding their movement. Okay, yeah. Can they be compressed?
Solid particles are packed very closely together and have a fixed regular pattern.
Okay.
Liquid, no, they are packed closely together. Do you want to mention about the not fixed regular pattern?
Actually, no. It's the packing that's more important.
Yes, they are far apart from one another and have no fixed regular pattern.
Okay. They're far apart. Okay, fine. Yeah, okay, which one is the answer?
One.
Mm-hmm.
Cell one has a cell wall and one large vacuole.
Large vacuole. Okay. All right. Does your school use the term central vacuole? No. No. Okay, because some schools they will refer to this as the central vacuole. But yeah, anyway, your answers are correct. Okay, what's the difference in location of W and X? Although they serve the same function in a cell. Okay, this is a funny question, but let's see how you answer.
It's just small, and when class W is located at the side near the central vacuole of X is centrally located.
Actually, I mean, you're right for cell one. There's a large central vacuole, so therefore the nucleus is like pushed to the side. But for cell two, there's no need to talk about the vacuoles there. All right. Anyway, they draw all those stuff you don't even know what they are. So yeah, the nucleus. Therefore, the nucleus occupies the central region. Okay. You know what is meant by organelles, right? So it's more like the stuff in the cytoplasm. All right. So basically, for cell number 2, there are no organelles blocking the position of the nucleus. Okay, this one shouldn't be a problem. Yep. What's the arrangement?
Well, tissue organs is the
Okay. Organ?
Different tissues made up of the same cell.
Many different issues made of the same cell. Go ahead.
Come together to form.
You miss out one important point though. An organ consists of different tissues, but also importantly, coming together to perform a function. Okay, I think I've given you one example, right? What are the others? Okay.
System.
nervous system. Okay. Okay, this one, what's the system here? Circulatory system. Okay. I assume you know how to spell all of them, right? Last column. Sure. Go ahead and write. Tissue. Well, you can put the word muscle if you want, but I mean, if you want to be a bit more specific, then I'll call it, let's say, smooth muscle. Okay, now, probably there's no need to know there are three types of muscles. Three types of muscle tissue. Three muscle tissues. But this helps you to understand better. One is, of course, your skeletal muscle. Skeletal. The other one is smooth. The last one is very special, cardiac. Alright, skeletal is of course for you to move your arms and legs. Alright, smooth will be in your digestive system, helping to push your foot down. Alright, cardiac is very special, it's only found on the heart. So organ, do you put anything for organ? Oh no. I mean at that time I told you all, because Xinchen was asking about this. Yep, I'm not really good. Okay, this is for the legs. How do you draw the leg ring? Let's take a look. You don't? Okay, I thought that time I printed for you, right? You don't? Okay, then what do you have? You mean that was the last page already? Is the basic division of reason, reason, security mirrors. Okay, let me try to clean it up. I can work on that. May, are you done? Okay. All right. Let's take a look. Huh? Right. Which question?
This one.
Oh, okay. 4A part 2. Okay. Yes. You managed to draw the light gray? Okay, can. Well, but haven't you heard the term periscope before? At night. It helps to see where. Okay, so yeah, basically, oops, one. How come I jump back here? All right, so yeah, you're right. One is in the use of a submarine. Okay, basically to see the surface, water, while staying underwater. The other one is basically to see around corners. Alright, obviously this can be done on the ground. You don't need to be underwater to do that. Okay, yeah, that's all you need to say. What's the other question? Okay. After which is the cup of coffee before drinking. Okay. Well, I suppose the question is asking why he stir. Alright. And not why he leaves it to stand to cool. Okay, first thing first, what are we looking at? Coffee powder, water, you boiled it. Okay, simple question. What is coffee? Okay, make sure is the solution. So what is it? Good. Now, usually what happens in a suspension? All right. But that is one possibility. But in this case, there is also something. Have you heard about the terms called settling? Yeah, that means they'll settle down to the bottom. Okay, that's called settling. But okay, without talking about that, basically he wants to make the suspension more uniform. Okay, by mixing the right the solutes. Okay, maybe I shouldn't use the word solids because it's more tied to solution, the constituents. volume of the coffee. Okay, so it's not trying to make it in the solution. There's no way to do that. But of course, this is only temporary. I hope you realize. By making it more uniform, it only stays there for a while because sooner or later the suspension will probably become settling again. Some of the stuff is settled down. Okay, but there's about this. Okay, what's the other thing? This one is quite silly because you don't know. Yeah, because it's quite silly because you don't know what to write, no? But actually, it's asking you about the arrange the hierarchy, right, from cells to tissue to organ, all right, and to organism. I mean, hopefully your school will not ask this sort of question, but if they ask, yeah, that's what they are looking to see. And which one? Oh, okay. That's all right. But are you done with that? Okay, let's go through. Okay, this one. How the virtual images are formed. Okay, anyway, I hope for both cases, your image is here. Right, the only thing is how do you draw the light rays? Okay, I don't think that is very, may not be accepted. All right, you know why? Because your light rays, uh, they are, okay, maybe I draw it on the screen. Because you drew like this, you started like this. But you know how you end up? You end up at the X, no? At a point, no? By right, because you started at here and here, you should end up with the same kind of image. That means a circle or an oval. All right, you should not end up in a point. Okay, but otherwise they are okay. So you should have something like this. Instead, I would prefer that because this thing is quite wide, I would just prefer you to work on a point instead. That means select one point. All right. And then let's see how I'm going to draw it. It's quite hard without a ruler. I try it here. Here, then it bends upwards. Is it a bit hard to show the bending though? Mm, let me zoom. Okay. Tell you what, I'll start from this point. Let's see. Because you may want to start from the image. And then quite hard because your eye is a bit small. I would prefer that they have drawn a bigger eye. So I suggest rather than look at the whole object, you concentrate on a point. Okay. But of course, reminder, I think the key thing that your teacher will be looking for is this. Once your light ray comes out, make sure it bends outwards. So this is a bit exaggerated, but you get my point. Okay, make sure it's something like that. Same thing for here. So if you want to get a point, I will just erase this one first. So let's say I identify the image first, then from here use your ruler, join to the eye. Okay, and then hang again. All right, so make sure you show the bending. Okay, I think the thing is a bit laggy. So basically, you make sure you draw a line from here to here, then a line from here to here. Okay, imaginary lines, make sure they are dotted. Direction, arrows must be there. Always going towards into the eye. Always into the eye. Yeah. Okay. So, yeah. I shan't. Okay. Indicate on diagram the position of the virtual images of each of the table. Now, even though your lines are pointing to a point, but there's no harm in drawing a image of the object. Okay. Okay, let me see anything else. Melting? Yeah, what's melting? Sorry. Okay, that's fine. But personally, I would prefer you to add in at the melting point. But just to be sure, because this question here, they did not mention explain in terms of particulate nature. So technically, if you don't want to mention particles, it's still okay. Basically, it's a change of from a solid becoming a liquid at the melting point. But obviously, some questions will ask you to write about particulate nature. Then you have to mention all the particles gaining energy. All right, then they start to move, overcoming the forces of attraction. For you? I'll just add in at the boiling point. Condensation. Okay. Okay, let's see what's next. Yeah. Okay. Anything else?
Particles start moving from an area of higher concentration to an area of lower concentration.
Okay, make sure you include that, the concentration part. Good. Okay, this one we've gone through. How about table, salt, sand, and water?
People salt and water mixture as the filtrate.
Okay.
Then I'll use simple distillation.
What happened to the sand? Yeah, did you write that now? Oh, you did. Okay, then that's fine. Sorry, after that, once you have the filtrate. Distillation. Okay, go on. Distillate.
Distillate. And what's the thing?
Which thing?
The thing that's left in the boiling
People boiling tube. Sometimes they call it residue, but your marker may not approve of that, no? You know why? What's the purpose of distillation? Do you know that there are two types of distillation? And their purposes are different. I won't say, okay, try not to use the word similar, because if they are too close together, you still can't separate them. That means if one is 70, one is 75, you still can't separate them like that. So I would prefer not to use the word similar, just I would say different boiling points. Separate what? From what? Let's be more detailed. Basically, simple distillation is to separate the solvent from a solution. You want the solvent, but not so much the solute. You know why? Because if you try to do it at the end, whatever's in the flask will be very concentrated, and the last bit of solvent will be very, very hard to remove. It's really hard to remove, not by distillation. So you're more interested in collecting the solvent. So since your school mentioned that two types, if you want to use distillation, you have to use that term, simple or fractional. You have to, can. But of course, in this case, you can't use either. What should you use? After you have the filtrate, which is a solution of salt and water. What's the other method you can use? Yes, they want the water too. Actually, they didn't really say that so clearly, so maybe we can close one eye to that. Okay, crystallization will be fine. What's the other method besides crystallization? Because if you really do a distillation, let's say simple distillation, whatever's left in the flask, that last bit is very hard to remove. That last bit is very hard to remove. You can't just do distillation. So for salt, let's say normal table salt, then evaporation to dryness will be most efficient. Next, all right. Okay, how do you answer for this? Good. Okay. 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 But make sure you have the words multicellular. But of course, some schools will use the term unicellular. If you want single, I think that's acceptable as well. Okay, yeah, fine. Basically, the rabbit is more efficient as an organism. How about 4A?
They are made of convex mirrors, which gives a wider range of view, allowing the staff to see everything happening in the store.
Okay, yeah, fine. Make sure you mention the term convex, wider angle of view or wider angle. Yeah, I think that's what they use. Okay, anyways, 2 marks only. So, all right, anything else? No? Did I miss out anything? No, right? That's all. Okay, you have any questions? If not, I'll just quickly go through some of the things, make sure you really know most of them. Okay, this is a slightly more difficult question, but I'm sure your school is capable of giving such questions. Have you seen it before? It's a bit unusual. Oh no, look carefully. Clarity. So you are adding more and more solid, right? So by right, at time 0, it should be clearest. And what's the clarity? Yeah. So a clear solution is right at the beginning. And you should put 100%. Okay? Put in the percent as well. Or for the method, you know the term saturated? Not necessary. That means the solvent has the maximum amount of solid dissolved in it. Maximum amount. But for the matter, look at part 3 as well. What is the meaning of point B? Why is there a drop in clarity? Suddenly it's become less and less and less and less clear until 0. 0 means no light can pass through. That's the implication. Okay, so point B is the point of saturation. Right? So you add and add until it becomes saturated here. And for this answer, guess what? It's still the same. All right, it's still 100. So only beyond saturation, then the clarity starts to drop down. I think there's one more. How about this one? Last. Yes. Okay, good. Basically, you have more solvent and some of the, basically, what happens at B to C is you have a lot undissolved solute. So if you add more solvent at C, that some of the solid will dissolve back into the solvent. And that, of course, increases the clarity. Okay. I mean, of course, I don't know whether this will come up for you, but it's, I would say, a more unusual question. You need to write down anything? Okay. Okay, anything not sure about this? This is basically your syllabus. Okay, just a question for you then. What are the factors that affect the rate of dissolving and solubility? Okay. One more.
Isn't that much?
Okay, one more.
Isn't that rate of dissolving?
Yeah, it's when the rate of dissolving. Of course. Oh, okay. I mean, I lump them together, but the rate of dissolving is affected by the stirring rate. All right, solubility, not so much. Okay? Yeah, you're right. Okay, let me see. Anything else? So you're okay with dot cross diagram now? So are you fine with all these properties of materials? Remember which one?
Definitions.
Oh, okay. I thought they will ask you for the definition because it's quite technical. But basically, electrical conductivity means how well it conducts electricity. I mean, there's a value for it, but you do not need to know the units. Same thing for thermal conductivity, how well it conducts heat. It's actually quite primary school stuff, no? If you look closely, except for density. I assume you have no problem with density, the formula at least. However, just be a bit, remember, it determines whether something will sink or float. All right. So if something has the same density of water, what happens to it? Basically, it won't move up or down. Wherever you pull it, it will just stay there. Okay. Else, these are fine, right? Do you need to remember all the accuracy, calipers, how to use it, right? Yeah, but you have to remember the accuracy. Right, so I think I've written down here for you. Calipers is 1 decimal place, mm. Does your school mention this? Micrometer? So caliper. Okay, so mm. But what's the maximum range? Can you remember? Calipers? Yeah, about there. It's actually 15. Most of the time it's 15, but fine enough. Okay, it's not that big. All right, so if you're asked to measure a big long thing, just use a measuring tape or maybe a ruler. But of course, ruler typically is at most 1 meter only. Okay, but measuring tape can go to a few meters. Volume displacement, I think, should be fine. Do you know what's meant by volume displacement? How do you measure the volume of a solid? Okay, then.
First, check the volume of the water.
Mhm.
Then you put the solid in and see how much the volume of water increase.
Okay, yeah, and that's volume displacement. Okay, so yeah, make sure you know that concept. There was something else. Do you emphasize much about compounds like non-matter plus non-matter, matter plus non-matter, or they don't really classify this yet?
Or like dot.
Yeah. Oh, okay. Okay, so make sure you know which is a matter, which is non-matter. So matter and non-matter, how do they form? So make sure you remember your dot cross diagram. square brackets. Charge. Okay, now I think you seem quite confident on that, so I won't mention that too much. Yeah, I think that's about it I want to tell you. You have any final questions? Not really, yeah. One last thing, just now I mentioned the word alloy. Alloys are considered metals as well, but it's a mixture. It's not a pure elemental metal like iron or zinc. Okay, it's a mixture. Alloy is still a metal, so that means alloy can still conduct electricity and heat. Yeah, I think that's about it. Okay, so you still have 1 more week to go, right? Yeah, I'll see you next week. Okay, bye.